Smart missiles are at the forefront of modern military technology, representing a leap in precision, adaptability, and efficiency on the battlefield. Unlike traditional missiles, which rely on pre-programmed trajectories and often lack the ability to adapt mid-flight, smart missiles are equipped with advanced artificial intelligence and machine learning capabilities. These technologies enable them to process real-time data, adapt to changing conditions, and make decisions independently, ensuring a higher success rate in combat scenarios. The core of smart missile technology lies in its sophisticated onboard systems. Using an array of sensors, including radar, infrared, and optical devices, these missiles gather vast amounts of information about their surroundings. This data is processed instantly by AI algorithms, allowing the missile to identify and prioritize targets while avoiding obstacles and countermeasures. For example, if an enemy deploys electronic jamming or decoys, a smart missile can recognize the deception, adjust its path, and continue toward its intended target with minimal disruption. One of the most impressive features of smart missiles is their target recognition capability. Unlike traditional missiles, which require precise coordinates to be effective, smart missiles use AI to analyze the battlefield and distinguish between legitimate targets and non-combatants. This significantly reduces the risk of collateral damage, making them ideal for missions in densely populated or high-risk areas. Additionally, these missiles can adapt to moving or evasive targets, such as agile fighter jets or high-speed naval vessels, which would be difficult or impossible for conventional munitions to engage. In air-to-air combat, smart missiles provide pilots with a critical edge, enabling them to engage enemy aircraft with unparalleled accuracy, even in highly dynamic situations. In air-to-ground operations, these weapons excel at striking fortified positions or critical infrastructure with pinpoint precision, minimizing the need for multiple sorties. They are also proving invaluable in counter-drone operations, where precision is required to neutralize small, fast-moving threats. Despite their advantages, smart missile technology is not without challenges. Developing and deploying these systems is costly due to their reliance on advanced hardware and computational power. Environmental factors, such as extreme weather conditions or electromagnetic interference, can also affect their performance. Moreover, the integration of AI in weaponry raises ethical and regulatory concerns. Autonomous decision-making in combat scenarios prompts questions about accountability and the potential for unintended consequences. Looking to the future, the potential for smart missiles is vast. Hypersonic versions could combine speed and intelligence, making them nearly impossible to intercept. Advances in quantum computing could further enhance their processing capabilities, allowing for even greater adaptability and efficiency. Additionally, multi-domain applications, including land, sea, air, and space, will expand their utility, redefining the role of precision munitions in modern warfare. Smart missiles are not just an evolution of existing technologies, they are a revolutionary step forward. By integrating AI and machine learning, they address the complex demands of modern combat, ensuring higher success rates, reduced collateral damage, and greater operational flexibility. As nations invest heavily in this technology, smart missiles are poised to become a cornerstone of future military strategies, shaping the landscape of warfare in the years to come. Smart missiles represent a revolutionary,